Okay, I just want to kind of quickly go through the step regression um, examples. Now, the idea of stepwise regression is that it allows you to kind of find a model by selecting a certain subset of the independent variables from, all the possible independent variables. If you have a huge data set with like 100 different columns and you're not quite sure what to put in your model, it will select a certain subset of those columns that are useful and you can build a model with those. In a way, it's a little bit like the tree methods because the tree methods actually do select the useful variables as part of the method. But regression, you actually have to choose your independent variables. Now, what I suggested to kind of quite a few of you is you'd start off with a few intuition models, i.e. variables that you think are going to be useful, and then you follow up by building some sort of a stepwise regression model to automatically choose the variables. So let's kind of start. Let's load in this data set. This is the housing data set that we had for the regression week when we did the stepwise regression. Note I've put strings as factors equals true. You don't actually have to do this for regression because it will automatically calculate string variables as factors, but it does make things a little bit easier to play around with. So let's just have a quick look at the Ames housing. So we have lots of information, a mixture of numeric and categorical data. Oh, where do we go? Let's just go to the end. The last piece of information is the sale price. That's a dependent variable. Something to notice is the first two columns are not really very useful. The order doesn't contain any useful information that might predict the dependent variable, and neither does this kind of ID. And generally, before you do any stepwise regression, if you have any kind of either categorical variables that just have too many categories, have more than 10 categories, or text data or messy data that doesn't mean anything, you need to remove it. So here we're going to remove those first two columns. So remember, rows, comma, columns minus C1, comma 2 is just basically -1 and -2. There we go. So we're going to remove those rubbishy columns. Now remember, we kind of, in the regression practical, I'll just go through this again. We built two models. So we built a model with just like the size of the lot and the size of the living area. And that had an R, everything was significant. I had an R squared of 0.5, adjusted R squared of 0.5. Then we kind of added the neighborhood. And you can see that this just increased the R squared from 0.5 to around 0.75. So that was the adjusted R squared. So increase the R squared from 0.5 to 0.75. And again, this was like location, location, location. You basically have, let's just kind of have a quick look at this. This is the price increase based on, I'd have to have a look what the base neighborhood is. But for example, a house in Northridge, which I think is one of the premium neighborhoods, costs on average $46,000 more than the house in the base neighborhood. Green Hill, $80,000 more than the base neighborhood. And I guess Edwards is not a very nice neighborhood. Average house is $65,000 less than the base neighborhood. So now we won't bother with the plots. Let's kind of move on to the stepwise regression. Here we're getting rid of missing data. But remember the two previous examples, I showed you better ways with mice of dealing with missing data. So we're just basically saying, we're just taking all the complete cases. And then for the stepwise regression, we need to build two models. We build the start model. And this, if you just kind of do a summary of this model, this is literally just a regression model with, when we have a 1, this is just literally the intercept. So we have the intercept only in this model. Then we have the full model. And if we do a summary of the full model, you can see that it basically has absolutely everything in it. It's got everything, even a lot of non-significant variables in. And the stepwise model works. It goes from the base model, and at each step, it finds the best variable to add. How it does that's a little bit beyond this course, but it kind of adds variables and variables until the criteria it uses, in this case, it's something called the AIC, which is like almost an inverse characteristic of the adjusted R squared. Basically, the lower the better. And it keeps adding variables until our regression can get no better. So the base model tells it where to start, i.e. it's going to start with a model with just the intercept, no variables, and the scope tells it where it can move around. So it goes from the base model with no variables to the full model with everything in it. The idea will kind of start off at the base model and kind of add variables until it goes no further, so the regression model doesn't improve. Direction equals forward just sets the direction. You could also do the opposite. You could start at the full model and go backwards, but we're just going to go with the basic stepwise regression. So let's go down. And note that at each step, as you see, it's adding a variable. This regression is getting one more variable each time it runs through. So I'll just like pause it until it's finished running. Okay, so we have the step model. Let's just do a summary of this model. Let's just have a quick look here. And we can basically see it's almost as big as the full model, but not every variable is included. So just like have a quick look at the kitchen, and you can see that the quality fair is $26,000 less than the base category. Quality good is $23,000 less than the base category. Quality PO, which must be the highest quality, I don't know what that means. That might be something to do with it being nearly new. And quality TA is, again, quite a low quality, is less than $25,000. You'd have to look at the documentation for the data set. But one thing we could do is we could actually just see what the levels are to see what our base level is. So we could actually do levels. And it's Ames Housing 2. I've spelled it wrong. And you can actually see that the middling category was actually excellent. So let's just go back to our, where were we? Our kitchen quality. And obviously PO must be some sort of perfect. And these three so it's 8,000 more than excellent. And these three categories are all a lot less than excellent. Okay, and we could see the model. We can just have a look at the R squared. R squared is 0.9233. Adjusted R squared is 0.9, almost 0.92. So a little bit more than the full model. I think this is the data set where nearly everything is useful. So we've only actually removed a few variables. Now, interestingly, stepwise regression can be used with logistic regression. So if you have a similar issue with logistic regression, you've got a lot of columns and you don't know what you want to include, then you could actually use logistic regression. So we bring in our youth survey, which we've used before, but this is like the full version of the data set. So it's like preferences. I think it's East European youths made for various things. And there's some demographic information. And we have here gender information. So based on all these kind of psychological variables, such as your types of favorite music, how you believe in health, changing the past, number of, how you respond to new environment, how many moods things do you have. We want to see if we can predict whether somebody is male or female. So it's the same thing we did with the actual tree classification in the previous example. So we've already seen this data set before, and basically all I'm doing here is I'm picking all the numeric, the survey columns, these measures of behavior, these measures of preference, and I want to see if we can do a stepwise regression doing all of these to predict whether somebody's male or female. And as we did last time, we're going to use mice to remove the missing data. Probably the easiest way to do the missing data. M equals 1, we're not bothering. Multiple imputations is a good thing to do, but for this class, we're just going to get one full version of the data set. We're going to complete. And while that's working, I'll just pause. Okay, so we've actually just resumed that. So we now have the mice data set. And so we just do the complete. And the logistic regression is exactly like before. Let's just check after we've done mice as usual. Just check we don't have any missing data left because it occasionally doesn't work. And so here again, this time we have a base model which has just the independent variable. And then we have a full model that has everything. We don't need to go through this again. We start off at the base model. We go from the lower model to the full model going forward. So let's just run this now. And before I pause it, I'll go through a few iterations. So you see life struggles, PC plus war plus romantic plus reading plus shopping plus cars plus giving plus action plus branded coding plus spiders plus writing plus funniness plus dancing plus sci-fi plus heights. And we'll just kind of pause there. Okay, so we have our youth survey model. Let's just do a summary of this. And we could actually see, and we can see the most important variables. So let's just kind of have a look. The formula gender is life struggles plus PC plus war, etc. Now we don't actually explicitly say which of our levels is going to be a true on this. But given our previous tree methods, we can pretty much see. So generally, I think the positive on this, the one on the logistic regression, is actually male. Because you can actually see, for example, the PC is positive, liking war movies is positive, not liking romance, not liking reading, not liking shopping, but liking cars, not liking giving, but liking action movies, liking branded clothing, um, but not liking spiders, liking writing, funniness, but not dancing, liking sci-fi. I think these are all kind of indicators of someone being male based on the data set. And in fact, we could check, so we could do levels. Go the wrong way around. Up. Sorry, my data youth dot gender. I don't know why I put survey. Here we go, and you can see that female is in the place of the 0 and male is the place of the 1. So in fact, we're predicting as the 1, we're predicting males, and 0 would be the females. Not being sexist, this is just the order of the data set. And so again, you could actually see the things that are positive for males actually have positive coefficients here. And then we could do things like we could actually calculate the log odd. We could actually calculate the log odd ratios to see, for example, the increase of 1 in PC, how much bigger chance that you would have of being a male over a female. And let's just kind of go down to some of these down here, which are actually the less important ones. But don't like new environment, likes history, don't like animated, don't like internet, like techno-trans, like westerns but not gardening, horror, but like health, folk, don't like Latino, prefer money to friends, but like achievements, etc. But the top ones are the real kind of important indicators, and these actually match with the tree model that we did on the previous example. So just to summarize, we did standard regression and logistic regression with stepwise regression. And stepwise regression is just a way, if you have a big data set with lots of independent variables, that you could actually predict some useful subset of those variables for building a regression model.